So I was doing some statistic stuff, and I like ran into just like the coolest thing ever, or one of. So I was learning about the t-test, right? And like I studied a little bit of statistics in school, but it's not the same as if anything. So I never really liked statistics. I always been a fan of calculus, but I'm doing this new statistics thing, and the guy that's like going through it is so good. And so I really wanna. I don't know why everybody's texting me. I really want to talk about what he did. So we're talking about the t-test. So let's kind of go through it. So the whole idea behind the t-test is going to compare, all right, values. Let's say it's comparing like averages. So it's going to compare values from a sample. Okay, and then it like references them to a population, which is kind of like ridiculous. So let's kind of talk about what that means. So let's just kind of do the example the guy did. So in his example, he was doing like engineers versus English students, but I'm just gonna go English for engineering versus lit. So he was saying like he took a look at some engineering students and then he took at some lit students, right? And he was like looking at their IQs, right? So I guess trying to argue who's smarter, if you will, whatever. So he got a bunch of values. Like I think he had 15 students per, so it's 15 English and 15 lit, and 15 engineering and 15 lit. Excuse me. So at the end of the day, he get that the average for the engineering was like 112, right? And then the average for the lit was 104, I think, or something like that. Okay. And so if you take a look at these, it shows from the averages that the average student based on his sample was 8 points higher, right? And so it looks like, right? It looks like the engineers are smarter. So the question is, are they smarter? So it looks like the engineers are smarter, but are they as a whole? Are they as a whole? Like as a whole population? So I'm gonna put whole in quotes. So we want to know, are they as a whole? Like, can we, from that idea that these 15 kids, 112 and 104, right? By just looking at that, can we say engineers in general have higher IQs than lit students? And so that's what the t-test does. And I thought that was like really, really cool, especially the way he explained it. So the whole idea is you're going to take a population. I'm sorry, not a population. You're going to take a sample, the 15 kids. It doesn't matter how big your sample is. So the t-test takes a sample and it compares it, or it extrapolates it to a population. And so that's what the t-test is going to do. And when you really think about that, it's like, how? Think about how many engineering students there are, like in the state versus the country versus the world, like versus ever. Like, how do you define the population? Do you say, it's the whole class? How? And so thinking about the abstractness of a population, just kind of putting the whole abstract situation on, I'm going to say, let's just say the population is like the whole earth, whatever. So let's just say the population is a whole globe. We're going to take a sample of like 15 kids. And that would be like a dot on the earth. So like we're going to take that tiny little sample. And by looking at that sample, we're going to do a t-test and we're going to figure out the engineers versus the literate students. We're going to figure out the ratio of, is it good enough to say that engineers are smarter, than lit students in general across the entire world? That's a crazy, crazy powerful piece of math, right? It's crazy powerful. And so what we're trying to do is establish, what it does is it's going to pop out a p-value. So the t-test pops out p-value. Okay. And the p-value tells you if it tells you if your data is significant. So it tells if your comparison is significant, right? And I'm putting it in quotes because significant in itself I don't even fully understand. But the whole idea is, can we say definitively that they're related? Can we say definitively, like not based on just a regular average from your sample, but like as in general, can we say definitively, like in general, that there's a relationship, right? That there is data. I'll put relationship. And so in our problem, basically what we're trying to say is, can we say that engineers are have a higher IQ in general than lit compared to lits in general, right? Like that's a statement, and that's what the t-test is going to do. That's what the t-test is going to like solve for. Okay. And so it turns out t-tests can be done with Excel, and that's what he did, because Lord knows I don't know how to do it. It's a concept class, so whatever. But he did the t-test. He did the t-test on the two values. He did the t-test on the averages. He t-tested the averages. And so he t-tested the average of the engineers versus the average of the lit, right? And then the t-test, the p-value that popped out was, I think it was like 0.057. Okay. And so we got to know, how do I figure out my answer from that 0.057? So what I learned was the p-value, there's two situations. Three, but two. If the p-value is bigger than 0.05, we can't say that there's a significant finding. The comparison is not significant. Okay. And so what that means is that we can't say from our answer, because we got this as our answer. And so our answer definitely is going to take the value of bigger than 0.05. So from our thing, we cannot say, and I think I'll put that in black, I guess, or whatever. And so from there, from our sample, we can't say that engineers have a higher IQ in general. Okay. I'll just put more IQ in general than lit students. And that's the only thing we can say. We can't say anything more or less than that. And that's the thing about the t-test. It's very rigid in that you don't want to make like grand statements. You can't be like, oh yeah, engineers in general are smarter, because no, you can't. All we can say is that we do not have enough information based on the t-test to establish a significance between the values. That's it. So if you were to compare the values of the engineers as a whole, and what I do is I put the globe up. If you put the globe, right, and you take all the engineers, and let's say all the engineers are like light blue, right? If you take all the engineers and then you compare them to all of the lit students, right? You can't say that the average of all of the population, the average lit compared to the average engineering, we don't know anything. We don't know how correlated they are. Okay? We can't say that the engineers are smarter or have a higher IQ than lit. That's all the t-test is saying, and we get that from the p-value. But the thing is, it's really, really cool, because you only took 15 people and you compared them to an entire population, and you don't even have like the definition of the population. You just go compared to the population in general. It's ridiculous. I don't know how they do it. I kind of want to go figure that out, right? So we got that. So let me finish this off to finish off the second definition. So we know if the p-value is bigger than 0.05, the comparison is not significant, right? So the p-value is going to talk about, are these two things related, right? If the p-value is smaller than 0.05, and a lot of people like to use smaller than 0.01, to be honest with you, then we can say that there is significance between the value, which means that there is some truth. I'll put signif between the values. Okay. And so what that means is, let's say if, right, if for the problem that we're working, p was like 0.009, right? Then we could say it is, we can say that engineers in general have a higher IQ. And that's it. That's it. In general. I got to work on my handwriting. Have higher IQ. And that's the only thing we'd be able to say. Okay? That's all we can say. And technically, I feel like this statement on its own is kind of too broad. It's kind of too powerful to say. And that's only if Okay. But the t-test on its own, like if you think about the power that you can take a sample, if you just kind of going back to this idea here, you can take this tiny little dot of a sample, right? And this tiny little dot, and then compare it to the entire population via the t-test, makes the t-test alone like ridiculously amazing. So just something that I looked into that I thought was really, really, really cool. And we can use this for like anything really. And I can definitely see why people love stats so much, the people that do. So kudos to the professor that I'm like looking at right now for kind of showing me something new and giving me something more than calculus to look into.